if we look at an example of that, I lived on Tagari farm in northern New South Wales. Bill Mollison had the Tagari Farm Institute, and it was originally just a 5-acre property, and then it got extended out to 148 acres and had it still has 48 dams and 6 kilometres of swales and a very, very complex broad landscape. But Bill started on a 5-acre block of land, and a very ordinary block of land. Ordinary in that it was just a straight rectangle, had a road on the bottom. This was the sun side, so in the southern hemisphere, north was down this way. So east is over here, and the sun would track around the property like this. So west over on this side, east over on this side. And when you look at the property in its original form, had a house, 2-story house, about a third of the way up the block, and a driveway that came straight in. That was about it. And it was just a straight paddock, grass field. When you look sideways, it was just a hill, probably not quite that steep. It was just a straight hill, 5 acres, and a 2-story house in the middle. About a third of the way up the block. So there's no valleys, no ridges really, no real features, just a house and a driveway. And you'd either have to graze that with animals to keep it as grass, or mow it with some kind of machinery mower or tractor. And there wouldn't be many other choices you could do ethically to keep it as grass. That would have to be your maintenance. You'd have to bring in animals, or you'd have to bring in some kind of mowing machine. Otherwise, you'd have to plough it all up to stop it regenerating, or you'd have to spray it all with some kind of chemical, which ethically you couldn't do. You wouldn't want to plough the side of the hill and keep it ploughed to stop it regrowing, or you'd have to keep burning it every year. You don't have any choice. You've got to spray it, burn it, plough it, slash and mow it, or graze it to keep it in that condition. So you've got to do something. Most of those choices are not that ethical, and definitely not that productive on 5 acres of ground. There's no interactions really. So I ended up living on this property for 3.5 years when it was in 12 years of development. It was in its 12th year when I first moved on. It was about 9th year, and then it ended up being 12 years in establishment. What Bill did was he looked at this, said, okay, we don't have any features. We need to put some features in. We could put a dam at the top of the property, but it won't have a lot of catchment. So we won't catch a lot of water up there because it's a straight slope. It only catches the water from above, from the farm next door, and doesn't really easily fill up there. So we've got a dam wall around this, and we can excavate the material to make the little dam pond, but we'll have to run out on contour, on level, a catchment system in earthworks called a swale, which will also soak water into the landscape and catch it back to the dam. And then we can set that up so that it'll hold water, a certain amount of water, when the dam's full. That will catch back this way to the dam. and it will catch all this extra runoff from upslope, which was just another grazing property, which ended up being part of the institute in the end. But it would run back and it would fill this dam, and when the dam was full, it would back flood up the same swale line until there was a foot of water, about 300 millimetres of water, sitting in that long swale and soaking into the landscape through the soft mound. And then if more water kept arriving, it'd overflow and go down the slope. So we're trapping water like energy. Water's full of life, and it builds soil over a period of time. And it's the great mover of nutrient and the great eroder of systems if you get it wrong. It's just as bad as it is good if you get it wrong. So we put a level sill on here so it was really even and level and thin overflow, thin sheet of water. And then that water would just be lost. So there's a bit of area in here. This would allow us to grow trees very easily. So we could recover that landscape in trees. So we could plant trees along there, and they could be fertilizing trees. And there would be a dampened soil hydrology just below that swale. So you get a nice line of trees in there. And after some trees that improve the ground and create nice nitrogen-rich fertilizing mulch, you could also have fruit trees or any type of production you want. You could have timber trees, forage trees, bee forage, fungi forest, your choice, doesn't really matter, right? But it could be a diversity, because we know diversity gives us stability. But then we got plenty of room, so we may as well pick another dam up. Pick another dam here in the landscape, and we could fill that. But also we need a swale along there. And we could repeat it in the other way, in the other direction. And we'll put a little level sill there too. And the same thing would happen. We're getting runoff between the dams. We get an overflow from that dam in large rains. It's going in both directions. When it's full, it's overflowing, it's coming down this way. Again, we trap more energy, more potential life, with more tree growth. We've got another nice, stable, soil-creating system, water and forest now. So, diversity of trees, productive by our choice of elements. Now, there's still room. So there was room to put another dam in. Now actually there was enough room to put a dam in with a little island in the middle of it for wildlife. Because the dam's got a little bit bigger as we came a bit lower in the slope. So now we've got a little wildlife island, increasing more natural interaction. And we've got another swale running out, a level sill on the end, another bank. Swale bank, water coming off this spillway, water coming from rain that falls in between the swales. We've got more dampened hydrology coming down the hill, fills the dam, back floods out the end, overflows. And another line of nice productive forest. Now we've got a house, and we really don't want the house to get too wet in the subsoil there, and we don't want any surface water, so we're actually going the other way now. We'll put earth bank up there, that's a hard earth bank, and if there's any surface water, it's displaced away from the house and the house site and the house foundations. But the water carries on coming down here. And there was room to put in another pond. And it's getting bigger again. And this one could be full of fish because we've got extra catchment now, and we've got more regular water because there's a soak of water coming through the soil now, voiding the house, coming through the soil. And now we can put another swale in, going across on contact, and we could take that underneath the driveway and come out the other side. But we could put an overflow in the middle of this dam, in the middle of this swale. It doesn't have to be on the end. So we can catch water, and we've got water coming this way, we've got water coming that way off the diversion, we've got water coming down the side, only in times of rain. It goes underneath the driveway through a pipe, comes over the level sill here. When the water gets full in the dam, it backs up and goes over the overflow there next to the driveway. That allowed us to actually build a major food forest system, a very productive forest. So we've got quite a specialised productive forest now. This allowed us to build one final dam. Quite a nice fish pond dam here, rich in life. It still had a catchment swale going off it, but no overflow at this point, because the overflow ideally went off the side here. So any surplus water coming this way allowed us to trap water going that way and then back flood up the swale, but didn't overflow there. At the same height it overflowed here. And here it went underneath the road and sink off the property. No longer of use to you. It's no longer with you. It's left your little boundary. It's left your system. We were able to put food forest on that swale as well. Irrigation off this allowed us to plant the boundary of the property and put major plantings all around. But there's also this movement of water that we could, at any point in here, we could put in an animal system. We could put an animal system at the top if it was convenient. So we could put any type of animals, chickens, ducks, geese, mostly small animals on a small acreage. Animal system have manure. So we have a manure input. So now there's a natural flow, apart from everything else that animals might produce and functions they might perform, there's an animal manure flow downhill. And that then hits that swale and gets spread evenly like a manure tea, which builds extra fertility in the ground. It's only a certain amount, but it's an additive. It's an extra. So you then get better growth. That then spreads further down. That then spreads further down. So what you've got is a nutrient flow coming through the property. And it's not that it's a... Don't think of it as an oversupply now. We're not pushing it towards a massive input. It's just a small input that increases life potential. It's a fertility input that will be taken up by the diversity of life because you've got all these interactions. So that life diversity interaction input is absorbed by the system. But still, even with all this life-rich diversity that is now easily extendable, it's easy now to water other elements. It's easy to put a barrier plant in and around the edge of the property. It's easy to put a fence line around it. It's easy to fill the gaps between swales if you want them in trees. It's easy to put in crop systems because you've got certain amounts of backup, but you've got to sink. In the end, some of that manure nutrient, some of that life-rich potential is flowing off the property here. This is a sink. You can't ever trap it all. But you could just here put in a little pond, and you could fill that little pond. So right at the bottom of the property, you could put in a little pond. We've got our dams here, we've got our dams here, we've got a dam and swell here, and a dam and swell here, and a dam and swell here. We've got little water traps all the way through, a little water trap. We've got a soak and a trap, soak and a trap, soak and a trap, soak and a trap all the way through. We've got bands of vegetation all the way down the hill. We've still got area in between, but they're really fertile because they've got a lot of forest interaction. And right at the bottom, we've still got a sink. But if we just fill that up with gravel, it's going to be damp because it's at the bottom of the system, and we plant it to reeds. Reeds are natural filters. They're part of those shallow marine systems, those marshes, those shallow water systems, those shallow lakes and ponds and marshes, wetlands. They naturally trap. If you look at the bodies of reeds above the water, their bodies are up above. Their roots are anaerobic and they're down below the water, and they're natural filters. So as the water comes through, as it goes through the roots, they pick up nutrient, they pick up sediment, they pick up all kinds of elements into their bodies. That's what they do. That's what these natural systems do. That's why we use them on grey water cleaning. That's how biological cleaning systems mostly work with plants. They're all these wetland plants. The reeds, there's a classic set of global genus of reeds. Now, they'll pick that up, some of it. They won't pick up all the water, they'll pick up a lot of the nutrient, and eventually they'll clog that reed bed. That reed bed will get completely clogged. There won't be room in there for any more reeds, and the roots will totally take up the area. So your little reed bed here that you've just designed in as a nutrient trap, it's going to end up absolutely dominated by reeds. And the roots, if the more nutrient there is, the thicker they'll grow. But at that point, you're on site, you're in observation. You can move in and choose that timing. Now we're getting time into it. You've got a time observation point here. You say, oh, the reed bed's clogged. The water's just hardly going through the gravel anymore. Let's pull a load of that out. Let's take half of that out, or more than half, because they grow quite quick. Let's grab those reeds. Let's grab that. Let's grab that. Let's take it up there. Let's grab this here. There's an opportunity here. There's a niche in time. Your niche, that empty, you created an opportunity. This opportunity was an open system. You put an element in there that does a job. You took out half of it and brought it back, and let's say you put it in the animal house up here, or let's say you mulch some fruit trees here, or anywhere you can bring it back into the system. You can put it back higher up in the energy flow. Now, it may not seem like a lot because I tried to give you a simple example, right? But this is what you've done over here. You've taken an energy element that was going through this web, and at the right moment in time, you, the designer, grabbed some of it and took it back. You've put in an extra cycle. Now, you had to do that. It wasn't going to do it itself. It wasn't going to jump up the hill on its own. You had to decide where the best place to hold a high dam was. You did that. You decided where that was going to go. You decided that it needed that extra contour swale to soak water in. You had to decide to do that. Every element here you put in position, And this is a very simple example. This is not, I'm not saying this is, you go out and find a property like this and do this. I'm just saying this is a way to think about including elements that do more than one function and elements that back up functions for you. Every one of these then starts to multiply, starts to build fertility, starts to slow down the energy loss in the system, starts to take a longer track through the system. And that's just a simple example. That definitely is not where it stops. Once you start that positive diversity interactive gain, the energy gain potential keeps increasing for quite a long time. It actually never stops, but it just taper off a little bit as you get towards a really established climax system where a lot of the elements are at maturity, especially trees. And when your oldest trees, the trees that live the longest, are at maturity, there is a point where it gets very, very stable. And it stays in that stable state, only increasing a little bit over time, but still increasing. It never stops increasing. Especially if you have a positive human interaction that keeps just tripping a little bit of loss energy back in. It's like you just keep the wheel spinning just with a little touch. Yes, it takes quite a lot to build the wheel to start with, but then to keep it running, you hardly notice what you have to do to just keep it a little bit tickled, a little bit serviced, and you just got little trips and traps that keep the cycles going. This is what we're going to do. This is a concept and a theme of how we approach design.